Today we'll be doing an ArrayStack using the Java API, so the built-in API. We're going to be using the built-in methods instead of creating our own just to practice with them. So first, I've already created a main class. You can create another class as well. I'm using IntelliJ, and we'll call this class ArrayStack. So we're going to be doing an ArrayStack, an array queue, a linked stack, and a linked queue. So we'll just say ArrayStack.java. We're going to be using generics, I think. So public class ArrayStack of generic type T, and we'll implement Stack Adt. I don't have the Stack Adt file with me. I don't think I have it here. Oh, we do have it. Okay, so we'll implement Stack Adt. If you don't have it, you can just comment it out and add it later. So we'll start with that. Then we'll import java.util, I think. We can import the whole thing, or we can just import a few things. So we'll import java.util .ArrayList. So we're going to be using the array list, and we're going to import java.util .iterator. So remember the array list, I haven't done the notes yet. The array list is an index list. It differentiates from arrays because you can remove the whole index. So if you remove index 2, then an array list will skip from 1 to index 3, but if you remove index 2 in an array, it'll actually set it 2 to null, so 2 won't skip. It'll go index 1 holding a value, index 2 will be holding null, and index 3 will be holding a value, so it doesn't skip. You can't just take it out. So that's the difference between an array and an array list, or an array and an index list, which an array list is an index list. So here we'll create an array stack. An array list of generic type T. Array stack, we'll call it. And it's just an object reference variable. Then in our constructor we'll say public array stack. And we'll say array stack points to new array list of generic type T. I forgot the capital here. What else is wrong with that? New array list of generic type T. Oh, folks, forgot the brackets or the parentheses. So now we'll do the push method. So we'll say public void push. So it pushes an element onto the stack. It's going to take a T element. We're going to call ArrayStack, and we're going to call the built-in method add of the ArrayList class. We're going to add an element onto the stack. In this case, we're going to be using an array list as an array stack. Technically, that's what we're doing. We can see previous videos if you want to see us create an array stack from scratch. We also have done that in previous videos. So here we'll have public tpop. I think it's supposed to throw empty collection exception, so public stack throws empty collection exception. You can do that Or again, you can just return null if it's empty. So we'll just say if is empty, which we don't have yet. Throw a new empty collection exception, ArrayStack. So you can do that, or you can do this as well, if is empty. Whoops, you can we can comment this all out after actually. So we'll just say if is empty, if is empty. Then here we'll system.out.println empty ArrayStack. We can return null here. So you can either do this or this. It's up to you. If it's type T, you can return null. So we'll comment this one out. So you can say that's optional to do that. What's happening with this? Oh, okay. That got down there for some reason. And then we'll have here else. So if it's not empty, so if it's empty, do this. If it's not empty, then do this. Then else. This is a pop method. We will return ArrayStack.remove. And the remove method takes a parameter int index. So we'll say size, which we haven't done, -1. Actually, before we even do those, let's just hold off for a sec. Let's do is empty and size, because I don't like doing that when the book does that either. So let's just quickly do is empty and size. So that's pop. Here we'll do public int size. Public int size, return ArrayStack.size, so it's a built-in method, of course. And then here we'll have public boolean is empty. Return ArrayStack.size is less than or equal to 0. So size returns the built-in method ArrayStack.size for an array list. Then public boolean is empty returns true if ArrayStack size is less than or equal to 0. So I did this code. It's my code. You can use it. It's not from a book. It's not from a book. I just did it. I just did it from scratch. So I think most of the codes are my codes that I just did for assignments and stuff. So you can use them. It's whatever. It's just an open API, anyways. So after those, we can just do we can go back to here's to pop. So if it's empty, so if size returns less than or equal to 0, then throw this exception. That's done. Then we were doing then we're doing the else. So we'll say else. Return ArrayStack.remove. of size -1. So the remove method, you're going to have to look on the Oracle docs for the ArrayList class, but it removes size -1. So it takes an index we're going to call size, which is going to be the size of the list, the length I guess, and the index is going to be the length -1, like an array. That should be it. Then we'll have peak as well. So public returns t peak. Should throw an empty collection exception as well. Throws empty collection exception. So we'll say if is empty again for peak. Then we'll throw a new empty collection exception. We'll not linked, we'll pass into ArrayStack. So if it's not empty, then we'll return get size -1. So again, you can throw the null if you want. You can do that if you want the exception flow to not occur, or we can just I'll just leave it out here, and then we'll say else. So if it's not empty, then we'll return ArrayStack. Actually, we didn't need to put else there. We could have just we don't need the else. So we can just return ArrayStack.get size -1. So the size, get the size, right? Then subtract 1, and that'll give us the top index. So remember, the top is basically the rear or the tail. So the top is the number of elements and the next index for the element to go into. So if we're saying the length, which is the size, which is top, basically, which we didn't use top in this one, then it would be the length of our stack. But top, remember, is the next available element, the next available index, I mean, and 1 minus that would be the previous existing element. So it would be top -1. That's what we did before, I think. But we don't have a top, so it's just going to be that, because we're using the built-in implementation. So peak size is empty. We'll use an iterator here for the toString, just to switch it up a little bit. It's valid, so it works. It's good to note this as well. So we'll override toString, public string toString. So we'll create a string variable here, string str equals to empty quotes. So just nothing, basically just empty quotes. Then we'll create an iterator object reference variable. So iterator of type t, we'll just call it iter, itr, itr is fine. We'll point it to ArrayStack.iterator, our object ArrayStack, and the link, the ArrayList class has a built-in iterator method. It's iterable, so it means you can use an iterator on it, ArrayStack.iterator. Does it give us a description here? And IntelliJ. No, it just, let's see if it brings up anything else. Iterator. Try to hover over it. So it just says returns an iterator over the elements in this list in proper sequence. The return iterator is fail fast, so that's fail fast. It means that if the mod count is thrown off, or if you're using it while it's iterating, if you change the iterator while it's being used, then it'll throw a concurrent modification exception. Concurrent modification exception, I believe. Don't know if that's the exact definition for fail fast, but I will try to do the notes on that or upload them. So it's just from the java.util.ArrayList class of generic type E. I don't know if you can see that, but it says, I don't think you can, but it says public java.util.iterator of generic type E, and then iterator with 2 empty parentheses. It says returns an iterator over the elements in this list in proper sequence. The return iterator is fail fast. Specified by iterator in interface list, so the list interface overrides iterator, and then it says overrides iterator in class abstract list, returns an iterator over the elements in this list in proper sequence. External annotations org.jetbrains.annotations.not null, and it's from JDK 15. Open JDK 15. So we will do some, hopefully we'll do some notes. If not, just remember you need to create an iterator object reference variable of type T. Call it what you want, ITR, and point it to the built-in object.iterator. Of course, not every class will be iterable, which means you won't be able to use an iterator on it unless you implement it. And you might have to override something as well. So we'll try to do an example of that. So here we'll just say y itr.hasNext. And we'll say str points to str plus itr.next plus a space to space it out. Then we'll return str here. That's it. It has a built-in iterator, so it's pretty easy. So we create a string variable, we create our object reference variable, we point it to our object's iterator. Then we've seen this before, like with scanner. So while our object itr.hasNext, then str points to str plus itr.next. So you can just print it out with system.out, but it may not store it properly. So that's why it's good to use a string variable to store it in a toString. If you just go system.out.print, it may skip some stuff for some reason. I've had that happen to me before, so just all it's saying here is concatenation, so it's taking on the first iteration. Because while it's holding a token, then it'll say str, which is empty quotes, equals to the empty quotes plus whatever itr.next. So if it has empty quotes and our object has 5, 6, 11, then we'll say 5, then on the next iteration 5 space 6, then plus a space plus 11. It'll keep iterating. You can do it you can see it in the debugger. It's you can create a breakpoint here or something and step through it in the debugger. That'll help. So I think that's it. I don't think we really need to test these. They're pretty straightforward. We're just using built-in lists. We don't really have to check if it works. The only thing that might be worth it is just to go through that if you don't have that memorized, and if you want to see how the while loop works, then just step through it. Set a breakpoint or something. I don't know if you can, but try to print something and set a breakpoint in main. So that should be good. There's no errors or things, so we got 3 more to do. Hopefully this doesn't close on us, because I actually didn't bring it to my desktop. So one sec, just pulling it up here. Downloads. So we just did ArrayStack. We might as well do the link stack just to switch it up instead of doing another array. Okay, it opened it up in IntelliJ. Didn't want that to happen. Open it up in... No, I don't want it in IntelliJ. Why is it doing that? Open. Hopefully it doesn't close the file here. No, it's actually not even opening here. Okay, so I think I put that on my other screen. Hopefully that doesn't lag. Actually, let me try to copy to a note file. Okay. It's kind of annoying. Can I get a new note file? I think it's because IntelliJ is open, that's why. Where's the note file? Note file's not even opening. New text document. Hopefully the window doesn't close here. Okay, so we have oh, that's the ArrayStack. That's not helpful. We want the one second here. Downloads, array queue, link stack. Okay, that's what we want, link stack. New text document. Delete all this. Okay, now we got that. So I did this for an assignment. So now we'll create a new class. And we'll just call it linked stack. No, sorry. Yeah, actually, yeah, linked stack. .java. What happened with that? So new linked stack.java. It already exists. Oh right, we already have one. So we can just hit new. We'll just call it linked stack built in. Just do BI or something. We'll call it BI. .java, that should be fine. And then we'll just have this, so public class linked stack BI of generic type T. So we're going to import a few things again, so we're going to be using the linked list and the iterator again. So we'll do iterator, and then we'll import java.util.linkedList. Node type T, so that's fine. We'll be implementing Stack Adt again of type T. So here we'll create a private field here, so private linked list of type T. linked stack. Linked stack. Is a linked stack? Yeah, it's a linked stack. So it's a little confusing. We're using a linked list to create a linked stack. It's kind of, they said in the textbook, I think I remember, it's not the proper way to do it. It's better to create something from scratch and use it properly, because it's kind of like I'm using a car to make a boat. Doesn't really make sense, but it probably can work. So that's, we'll just do that, and then we'll create a constructor. So public link stack. And we'll call our object reference variable link stack. We'll point it to a new linked list of type T. See, already it's a little bit confusing because it's like link stack and link list. Which one are we using? Because they're both different. One you can add to the front, the end, in the middle. One you can only add to the top. So then this will be our push method. So public void push takes a T element again. We'll call link stack dot add element. That should be it. Then we'll do pop here, public T pop. We'll throw empty collection exception. Throws empty collection exception. We'll say we'll do our if is empty first. Public boolean is empty. So it just throws. Again, we can return null or just throw our exception. Actually, no, sorry, is empty. It's just going to return linked stack dot size is less than or equal to 0. Same thing, because I think this size method comes from the list interface. So it should be same as array list. I'm not 100% sure, but I think so. So after that, we'll do the pop method. So if is empty, we'll call our method if is empty. Then we'll throw a new empty collection exception. We'll pass in link stack. Then we'll say else. We don't need the else. You can do it if you want. Because if it goes to exception, it'll just go here and the program will terminate. Unless otherwise that we change it. But we're not, so then we'll just leave it like that. We don't need our else, and we'll just return link stack dot remove last. That's it. It's easy, right? We don't have to do anything. We're just calling one method because it's the built-in API. And we'll do the size method here. It returns an int public int size. Public int size. Return array list. No, array stack. Sorry, link stack. Return linked stack dot size. That should be it. Is empty. We have. Peak we have. So we just need toString. So at override we can use an iterator again. Public string toString. You don't need to use an iterator, but it's useful because it's already built in. So we create our string variable, string str, set it to empty quotes, create our object reference variable of type iterator, iter, for itr, points to linked list, link stack, dot the built-in iterator, should work. Link stack, sorry, no, it should be linked. Link stack. Or, yeah, it should be this. Should work. Okay, it works. I thought maybe we were gonna have to call linked list, but it is a linked list. So we just call our object. So what it's really doing is calling the linked list iterator. That's all it's doing. So after that, we'll say while itr.hasNext, str points to str plus itr.next, plus a space. Str points str plus itr.next plus a space. Yeah, that's right. Then we'll just return str. That's it. Nothing too hard. It's all built-in stuff, so that's fine. Peak, do we do it? Link stack, there's no peak. No, there is a peak. Yeah, we didn't do peak. I thought we did do peak. Push pop. Okay, peak should be in here. I was thinking first, because sometimes they call it first, but for stack it's called peak. So public t peak throws empty collection exception. So if is empty, we'll throw new empty collection exception, link stack as a string. Then otherwise, we'll just return linked stack dot get last. That's it. What's wrong with this? Whoops, we didn't call it BI. Excuse me. That should be it. It should work. We're not going to test it. It's just built-in stuff. But in main, you can just create an object linked stack BI stack equals a new link stack BI of whatever object type you want. And you can test the methods yourself if you need to. It should work. So we'll just take a break and we'll come back and do the queue. See you in 5 minutes.